Welcome to Unit 8. Unit 8 is all about estimating area under a curve. This is definitely different than what we've been doing before, but it's kind of similar in that we are going to relearn a geometric way and then we're going to do the same thing using calculus in Unit 9. So right now we're going to stay in just geometry using either area or area of a rectangle or area of a trapezoid. This unit might be a bit confusing in that we're not learning a lot of calculus, but I've really tried to pare it down to exactly only the things that you need in order to be successful on the exam and not the extraneous information. Although the extraneous information is really good for understanding, we don't really have a lot of time this year to learn material that's not necessarily going to be assessed. Now we're up to 7.6, which sounds like we're going really far ahead, but it's just another way of estimating area, so I thought we should put all of our area stuff together. We've done left Riemann sums and right Riemann sums using rectangles, but now we're going to use the trapezoid rule. As you might have remembered from that first example we did, we had a trapezoid. We didn't actually find the area using a trapezoid, but it looked something like this. We were looking for the area underneath here. And underneath here was definitely a trapezoid. And generally speaking, trapezoids, even if we have a function that looks like this, a trapezoid is going to give us a better estimate because it's just a little bit better hugging those curves. I'm not drawing very pretty trapezoids, but it's a little bit better hugging the curves than a flat line of a rectangle. They give us this really in-depth equation for remembering, but we really don't need that equation. I'll give it to you and I'll talk about it, but we don't really need to use it. So we're going to use, this is a more accurate estimate, but still an estimate. The integral from a to b of f of x, and then they give us this b minus a over 2n, and then the y value for the first interval times plus 2 times the y value for the second, all the way plus 2 times the y value for the second to last, plus the y value for the last. This is a lot of an equation to remember, but I could just remember my area formula for a trapezoid. And if I just remember my area formula for a trapezoid, that's really all I need. That the area is 1/2 base 1 plus base 2 times the height. So in example 5, I'm going to be using that formula, that the area is 1/2 the height times base 1 plus base 2. If you don't have this formula memorized, this is something you want to memorize because it's much easier than memorizing that crazy equation. So I can't really see these last numbers. It's 120 and then 140, and I have 144 here and 158. All right. A 140-foot tree has a trunk. A tree trunk is cut into 20-foot logs. The diameter of each cross-section cut is measured and the area A is recorded in the table below. X is the distance in feet of the cut from the top of the trunk. And the question's asking us to find the approximate volume of the trunk using the trapezoid rule. So what we're going to do is find the area, or estimate the area, from 0 to 140. So our volume is going to be about 0 to 140 of each one of these areas times dx. Okay, so let's take a look at this first one. In this first block, my width is 20. And my bases are 120 and 124. Again, that's just my trapezoid rule. In this next block, I'm going to go from 20 to 40. My width is 20 again. 124 and 128 are my bases. Then the next one, my width is 20 again. And my bases are 128 and 132. My width is 20. And my bases are 130 and 132. My width is 20 again. And my bases are 132 and 136. My width is 20 again. And my bases are 144 and 136. And then the final block is right here. Again, between 120 and 140, my width is still 20. And I go from 144 to 158. Those are my bases. So there's a lot of ways to do this to simplify. If you notice, we have 1/2 times 20 in every single piece. Right here, right here, right here, right here, right here, right here, right here. So I'm going to pull that 10. 1/2 of 20 is 10. I'm going to pull that 10 out. This is not super important, but it helps me know how, like, it helps me simplify. And then I'm just going to add each piece. So this one's 244, 250, 252, 260, 262, oops, 268, 280, 302. So I'll add all these up and then I'll multiply by 10. And I get my volume is about 18,680. And let's see, that's going to be feet squared times feet, so that should be feet cubed. So a couple things are important here. We need to pay attention to what we're multiplying. That's how I got feet squared times feet cubed. So my units is always important. Usually the units are worth 1 point on an open response question, so it's important to have them correct. We'll do some more examples of these in class as well as for homework, so hopefully these will start making some more sense. I know that the equation looks really complicated, but in practice it's just a geometry problem.